Hello students, today we are going to discuss about alkenes. Alkenes, preparation and properties. As you know that alkenes are the unsaturated hydrocarbons containing carbon-carbon double bonds. Alkenes are the unsaturated hydrocarbons containing carbon-carbon double bond. The general formula of alkenes is CnH2n, where n represents the number of carbon atoms. So, in this topic, we are going to discuss preparation of alkenes and properties of alkenes. Alkenes are unsaturated hydrocarbons containing carbon-carbon double bond. They have the general formula CnH2n. The simplest member of alkene family is ethene, that is C2H4. The alkenes are also called olefins. In Greek, olefiant meaning oil forming, because the larger member of the series, such as ethylene, propylene, etc., react with chlorine to form oily products. So, alkenes are collectively known as olefins. Among the alkenes, the first stable member of alkenes is ethene or ethylene. Ethylene is a common name, but ethene is a IUPAC name. Ethene, propene, butene, pentene, hexene, heptene, octene, nonene, decene. These are the different members of alkenes. In this lesson, we are going to discuss the preparation of alkenes. Wrongly, it is written as alkanes, but it is alkenes. Preparation of alkenes. So, alkenes can be prepared from alkynes, from alkyl halides, from vicinal dihalides, from alcohols. So, alkenes can be prepared from 4 compounds. Number 1. Preparation of alkenes from alkynes. Alkynes can be reduced to alkenes using palladium charcoal, that is palladized charcoal catalyst, partially deactivated with poison like sulfur compounds or quinoline. Partially deactivated palladized charcoal is known as Lindlar's catalyst. Alkynes can also be reduced to alkenes with sodium in liquid ammonia, which is called Burke reduction. Anyhow, by reduction of alkynes, alkenes can be obtained. For the process of reduction, we can use palladized charcoal as a catalyst. Otherwise, we can also use sodium in liquid ammonia as a reducing agent. So, if alkyne undergoes reduction with sodium in liquid ammonia, such reduction is called Burke reduction. For example, 2-butene, but2-ine. 2-butene upon reduction gives 2-butene. Here, palladized charcoal is used as a catalyst. So, when 2-butene reacts with hydrogen, gives 2-butene. Similarly, propine, wrongly it is written as propone, actually it is propine. Propine upon reduction gives propene. Similarly, ethine means acetylene. Acetylene upon reduction gives ethene. Anyhow, by the process of reduction, alkynes can be reduced to alkenes. Alkenes can also be prepared from alkyl halides. Preparation of alkenes from alkyl halides. is carried out by the process of dehydrohalogenation. Dehydrohalogenation means removal of hydrogen halide molecule, that is removal of HX molecule, is called dehydrohalogenation. In this process, alcoholic KOH is used as a reagent. Therefore, we call alcoholic KOH as dehydrohalogenating agent. Example: when ethyl halide is heated with alcoholic KOH. When ethyl halide is heated with alcoholic KOH, loses a molecule of HX and gives ethene. So, in this process, one molecule of hydrogen halide has been eliminated. So, we call it as a elimination reaction, since halogen atom from alpha carbon and hydrogen atom from beta carbon has been eliminated. Therefore, we call it as beta elimination reaction. Nature of halogen atom and the alkyl group determine the rate of reaction. Alkene can be prepared from alkyl halides, usually bromides or iodides, by treating with alcoholic potash, that is potassium hydroxide dissolved in ethanol. This reaction removes a molecule of HX and therefore the reaction is called dehydrohalogenation. In this reaction, the hydrogen atom is eliminated from beta carbon atom next to the carbon to which halogen is attached. Therefore, the reaction is also called beta elimination reaction. Nature of halogen atom and the alkyl group determine the rate of the reaction. It is observed that for halogens, the rate is iodine is more reactive than bromine, which is more reactive than chlorine. While for alkyl group, it is tertiary alkyl halide is more reactive than secondary alkyl halide, which is more reactive than primary alkyl halide. Dihalogen derivatives from vicinal dihalides. Alkenes can also be prepared from vicinal dihalides. Dihalogen derivatives of alkanes in which two halogen atoms are attached to adjacent carbon atoms, called vicinal dihalogen derivatives, are converted to alkenes by heating with zinc dust in ethyl alcohol. Example: CH3CHBr bond CH2Br, that is CH3CHBr bond CH2Br plus zinc dust gives rise to CH3CH double bond CH2 plus ZnBr2. Wrongly it is written as ZnBr, it is ZnBr2. In this reaction, a vicinal dihalide has been taken. 1,2-dibromopropane has been taken. 1,2-dibromopropane on heating with zinc dust gives propene. So propene can be prepared by taking 1,2-dibromopropane, treating with zinc dust. Alkenes can also be prepared from alcohols. Alkenes are prepared from alcohols by heating with protonic acids such as sulphuric acid at about 443 Kelvin. This reaction is called dehydration of alcohols. By the process of dehydration of alcohols, alkenes can be obtained. For the process of dehydration means removal of water. Removal of water is called dehydration, and concentrated H2SO4 is used as a hydrating agent. Example is given ethanol on heating with concentrated H2SO4 or H3PO4 gives ethene. This reaction is also an example of beta elimination because OH group takes out one hydrogen atom from the beta carbon. Example equation is given ethanol on heating with concentrated H2SO4 gives ethene. Here OH group is bonded to alpha carbon and hydrogen which is bonded to beta carbon. The hydrogen which is bonded to beta carbon and OH which is bonded to alpha carbon will be eliminated as water molecule. So this reaction is also called beta elimination reaction. Let us discuss the chemical properties of alkenes. Since alkenes are unsaturated hydrocarbons, they undergo addition reactions. Addition of dihydrogen. Alkenes add upon molecule of dihydrogen gas in the presence of finely divided nickel, palladium or platinum to form alkanes. For example, C2H4 plus H2 in the presence of nickel or PT or PD gives C2H6. So by adding a molecule of hydrogen, ethene is converted to ethane. Secondly, addition of halogens. Halogens like bromine or chlorine add up to alkene to form Vicinal Dihalides. The reddish orange color of bromine solution in carbon tetrachloride is discharged when bromine adds up to an unsaturation site. This reaction is used as a test for unsaturation. Addition of halogen to alkene is an example of electrophilic addition reaction. So we can take an example, addition of bromine to ethene. C2H4 plus Br2 gives rise to C2H4Br2, that is 1,2 dibromoethane. In this reaction, when we pass ethene vapors over the bromine liquid, the red color of bromine will be discharged. This is a test to identify the unsaturation. Bromine test. This is also called bromine test. Bromine test is used to detect the unsaturation. All unsaturated compounds react with bromine and form saturated compounds. In this reaction, the red color of bromine disappears. It is an example for electrophilic addition reaction. Addition of hydrogen halide. Hydrogen halides, example hydrogen chloride, hydrogen bromide, hydrogen iodide, add up to alkenes to form alkyl halides. The order of reactivity of the hydrogen halides is hydrogen iodide is more reactive than hydrogen bromide, which is more reactive than hydrogen chloride. Like addition of halogens to alkenes, addition of hydrogen halides is also an example of electrophilic addition reaction. In this way, we can take an example C2H4. C2H4 plus HCl gives rise to C2H5Cl, that is ethyl chloride. When ethene molecule adds on a molecule of HCl gives ethyl chloride. Look at the example, addition of halogens. Addition of halogens, example is given, ethene plus bromine gives rise to 1,2-dibromoethane. This reaction occurs in the presence of CCl4. In this reaction, the red color of bromine is discharged due to the formation of colorless 1,2 dibromoethane. When propene reacts with chlorine gives 1,2 dichloropropane, 1,2 dichloropropane. So this is also an example for addition of halogens. Now addition of HBr to symmetrical alkenes. Addition reactions of HBr to symmetrical alkenes take place by electrophilic addition reactions, where similar groups are attached to the double bond. Ethene reacts with hydrogen bromide, giving rise to ethyl bromide. This is a symmetrical alkene. When butene, 2-butene, when 2-butene reacts with hydrogen bromide, here 2-bromobutane is obtained. 2-bromobutane is obtained. Addition of HBr to symmetrical alkenes. When HBr is added to propene, then it yields 1-bromopropane and 2-bromopropane. Here propene is an unsymmetrical alkene. When bromine is added to an unsymmetrical alkene like propene, two probable products are possible. One is 1-bromopropane, another is 2-bromopropane. Here more stability, secondary free radical. In the first reaction, more stability is associated with the secondary free radical. In the second reaction, less stable primary free radical is obtained. Now Markovnikov's rule. Markovnikov's rule is applicable to unsymmetrical alkenes. Markovnikov, a Russian chemist, made a generalization in 1869. This generalization led Markovnikov to frame a rule called Markovnikov's rule. The rule stated that during the addition across unsymmetrical multiple bond, the negative part of the added means attaching molecule. The negative part of the attacking molecule joins with the carbon atom, which carries smaller number of hydrogen atoms, while the positive part goes to the carbon atom with more hydrogen atom. See, according to Markovnikov's rule, the negative part is attached to the carbon containing less number of hydrogens, and positive part will be attached to the carbon containing more number of hydrogens. Mechanism of Markovnikov's rule. Let us apply Markovnikov's rule for an unsymmetrical alkene like propene. Propene reacts with hydrogen bromide. Two probable compounds will be formed. Here, in this case, in first case, primary carbocation is formed, which is less stable. In second case, more stable secondary carbocation is formed. The secondary carbocation is more stable than the primary carbocation. Therefore, the former predominates because it is formed at a faster rate. The secondary carbocation is attacked by bromide ion to form the product as follows. See, in this reaction 2-bromopropane is obtained. So 2-bromopropane will be the major product. Crash effect or peroxide effect or anti-Markovnikov's rule. In the presence of peroxide, addition of HBr to unsymmetrical alkenes like propene takes place contrary to the Markovnikov rule. This happens only with HBr but not with HCl and HI. This reaction is known as peroxide effect or Crash effect. The reaction for anti-Markovnikov's rule is as follows. When ethane reacts with HBr, giving rise to two probable compounds. One is 2-bromopropane and another is 1-bromopropane. 1-bromopropane is obtained in large quantity. So 1-bromopropane is the anti-Markovnikov product. According to anti-Markovnikov's rule, the negative part of the reagent is added to the carbon containing more number of hydrogens. When Br minus is attached with H2O, H plus will be attached with CH, so that the product will be CH3CH2 bond CH2Br. That is 1-bromopropane. 1-bromopropane will be the major product according to anti-Markovnikov's rule. Addition of sulphuric acid. Cold concentrated sulphuric acid adds to alkenes in accordance with Markovnikov's rule to form alkyl hydrogen sulfate by the electrophilic addition reaction. C. Ethene combines with sulphuric acid giving rise to ethyl hydrogen sulfate C2H5HSO4. Addition of water. In the presence of few drops of concentrated sulphuric acid, alkenes react with water to form alcohols in accordance with the Markovnikov's rule. Let us see this reaction with the propene. Here 2-methylpropene on treating with water in the presence of H2SO4 gives 2-methylpropanol. Oxidation. Alkenes react with cold dilute aqueous or alkaline potassium permanganate solution to form 1,2 diols called glycols. The glycols contain 2 OH groups on adjacent carbon atoms. This reaction of addition of 2 hydroxyl groups to each of double bond is called hydroxylation of the double bond. So when ethene undergoes oxidation in the presence of dilute potassium permanganate gives ethylene glycol or 1,2 ethane diol. Similarly, when propene undergoes oxidation in the presence of dilute KMnO4 at about 273 Kelvin temperature gives propane 1,2 diol. Ozonolysis is one of the important reactions of alkenes. Alkenes are oxidized with ozone to form ozonides, which are unstable compounds. These are reduced with zinc and water forming aldehydes and ketones. This reaction is called ozonolysis. Ozonolysis means this is a test to identify the unsaturation. Alkenes and alkynes undergo ozonolysis. In this reaction, alkene is treated with ozone to give a cyclic, intermediate, unstable and explosive compound called alkene ozonide. This alkene ozonide undergoes hydrolysis in the presence of zinc, giving rise to carbonyl compounds. So, when ozonolysis is carried out with propene, propene reacts with ozone, giving rise to propene ozonide. Since propene ozonide is unstable, cyclic, intermediate and explosive compound, in the presence of zinc and water, it undergoes cleavage, giving rise to acetaldehyde and formaldehyde. Anyhow, during ozonolysis process, ultimately we get carbonyl compounds. So ozonolysis is a test to detect the unsaturation. Lastly, polymerization. Polymerization is a process in which a large number of simple molecules combine to form a bigger molecule of higher molecular mass. The small molecule is called monomer. The small molecules are called monomers, while the bigger molecules are called macromolecules or polymers. Example, when ethene undergoes polymerization gives polyethene or polyethene. These are the chemical properties of alkenes. Thank you.